Thank you all for joining me today. I'm David Berkey. I'm an applications engineer here at Biamp, and I'm here today to spend some time with you to talk about our exciting new amplified loudspeaker controllers, the Voltera D and Voltera DM. And specifically, we're going to talk a lot about how those can be integrated into our Tesira platform. A little bit about myself. I've been with Biamp now, oh man, for just under about 8 years, and time flies. I can't even believe that. And over that course of time, I've had the privilege of working with a lot of talented people, both here internally at Biamp and both out there with our customers working in the field. I've sort of worn a lot of hats throughout my time in the industry. Everything from installation, programming. I've done a little bit of design, some occasional sales, and up to end user in-house support and manufacturer support here at Biamp. And I'll tell you, one of the things I feel like I love the most about our industry, and one of the things I've gravitated to, is I love troubleshooting. I really enjoy it. I love working with the support team here. And I love working together with all you folks out there in the field. There's something about being faced with a problem, right? Trying to figure out maybe why two things aren't quite working well together, or helping someone work through something they're struggling with, or even helping myself work through something I'm struggling with. There's of course some frustration with that, banging your heads against the wall trying to figure out maybe why something's not quite working the way we expect it to in the moment. But man, that aha feeling when you've been working really hard and you get to the bottom of what's going on, and working together with someone to do that is great. And so I'm sure a lot of you I've maybe spoken with on the phone, over a support call. I really appreciate all the time that I've been able to have with you, and I want to thank you for joining me today for this. Those of you I haven't met, welcome. I look forward to spending this time with everyone today, and hopefully we'll come away learning a little bit more about these new products. We got a pretty straightforward agenda today. Going to go over and we'll review the hardware itself. So we're going to talk about both Voltera D, DM. We'll take a look at the front rail panels, all the ins and outs, and just dig into what you get when you get that chassis in front of you. These are network devices, so we'll discuss supported network topologies, media protocols. We're going to get into our software configuration options, and yes, I say options because while we're focused on Tesira today, we do have a new software called VenueTune that's specifically designed to interop with the Voltera D products. Keep an eye out. I believe we'll be having a webinar on that coming up here towards the end of the month. And then we're going to shift into really what our main focus is today, and that's Tesira. How does Voltera D, how does this amplified loudspeaker control, how does it fit inside our Tesira layout? And so we'll take a look at the signal flow inside Tesira, the block, compilation, and supported configurations with Voltera D. And then at the end, we'll jump into that Q&A. So let's do it. What is Voltera D? Some of you may have run into it yet, but it's fairly new. So let's dig in. Voltera D really is, it is an efficient and effective way to drive Biamp loudspeakers. And in part, this is due to its access to our new Alamos library of loudspeaker presets. This is huge, right? It's our largest ever loudspeaker profile library, right? So we have almost 240 loudspeakers total that are supported in here. And in addition to those 240 loudspeakers, we have various presets for each, right? We have subwoofer options that are included for multiple crossover applications. We have tap options included for loudspeakers that have transformers. And all of this is put together to allow you to drop in preset EQ and limiter configurations and ensure that you're deploying systems with optimal loudspeaker settings, right? Trying to do as much of the work for you up front as we can to ensure you're getting the most out of your system. And these aren't just amplifiers, right? They're amplified loudspeaker controllers, right? So sure, there's amplification built inside, but that's just part of it. right? There's a full-featured pre-built DSP signal flow inside of Voltera, ready to go, waiting for you to drop one of those Alamos presets in. It's completely configured over the network, so there's no dip switches, buttons, attenuators, there's no bridging requirements, anything like that external to the box, right? This is all configured over software, right? It's not just an amplifier you're gonna throw in the rack, plug a source into input 1 and have it play out, speaker output 1, right? This, configuration is required. It's very loudspeaker focused, right? So you're telling each channel what loudspeaker you're driving, and using our presets, it's configuring that channel so you get the most out of it. We have 4 models that were announced initially in the Voltera D. We have 2 4-channel versions, as well as we have 2 8-channel versions. Each channel option comes in either a 2400 watt or 1200 watt chassis power. And you can glean all that from the model numbers themselves. So we have the D2404, for example, at the top of the list there. So that's 2400 watts of chassis power across 4 channels. And we're going to rate all these both with a symmetrical and asymmetrical power rating. And we'll look at that over a couple slides to kind of sort out what does that actually mean. But when you're looking at this, we've got, for example, the 2404. It's got 4 channels. All those channels driven simultaneously, you can get up to 600 watts out, right? And that maths out pretty easy, right? We got 600 watts per channel times 4 channels, you get 2400 watts. But depending on what your power requirements are, what your loads are across those channels, right? We can actually provide up to 1800 watts on any power, on any output, right? So that's 3 times that rated symmetrical power. When we look at the 8 channels, we have that same power sharing capabilities. So we have asymmetrical power up to 4 times the power of the rated channel, right? And we'll get into what that means here in a little bit. But each Voltera D can drive either low impedance or 70 volt, 100 volt high impedance lines, right? And mix across all the channels, either or. It's all based on the preset you drive in and how you configure that once it's added into your layout. And probably one of my favorite features about this is you get a small amount of DSP overhead. So I mentioned you've got an ALC DSP signal flow that's under the hood there. It's already pre-built, waiting for those presets to be dropped in. And that takes up a good bit of the DSP that's inside these Voltera Ds. But we get a little bonus. We got about maybe 5%, 8% of available DSP. And while it doesn't sound like a lot, that can be a powerful tool. There is local switching inside of the Voltera Ds, right? We have a matrix mixer inside of there, we'll take a look at, right? And so inputs coming in can be routed to any output channel local on the device itself. But what about situations where maybe you have multiple Voltera Ds spread throughout a facility and you have inputs coming in, you want to steer to all of them? Well, in that case, this little bit of DSP overhead will allow you to put source selectors, matrix mixers, right? We can proxy Tesira expanders. We can do input expansion across the facility and do some basic source switching ahead of that signal getting into the Voltera D. Now, keeping that DSP in mind, take a look at the Voltera DM. So Voltera DM comes with all the features that come with Voltera D, except there's 2 things that we want to focus on when we're looking at the differences here. We bring in a variety of different channel counts and power options. So 5 models were announced with Voltera DM. In that case, we have a spread of 2-channel and 4-channel options. So no 8-channel in the DM, no 2-channel in the Voltera D. The 2 and 4 channels here, we have a similar spread with the 1200 watts chassis power and 2400 watt chassis power on each. So we've added a 5th model into this mix, and that's the D600.4M. So that's a total of 600 watts chassis power there. These are all going to be rated with the same symmetrical per channel and asymmetrical power ratings there. But thinking about that DSP, we were talking about that overhead. Oh, we get so much more with Voltera DM. So on top of the ALC signal flow that's already pre-built in there for you, we have essentially what is the overhead of an entire Tesira Forte. And man, I am honestly excited to see what people do with this, right? Because to me, my brain's already churning on, you know, maybe large BGM distributed audio systems, connecting overflow rooms, like, and there's so much processing power in there already with that ALC signal flow. But now we've opened up and we've got all this room to add the processing that you could fit inside of a Tesira Forte. So situations where maybe you need a little more processing power than Voltera D, we can get the DM involved and it can support some of those other needs for you. I do want to spend a slide or two just kind of outlining symmetrical versus asymmetrical, right? So you'll see this on the data sheets, you'll see it on tables we have on Cornerstone. And right, for those of you maybe not run into this or come across this before, you know, when I think of symmetrical, I think of balanced, same, even, right, similar. And so when we're talking about our symmetrical power rating, we're really talking about, you know, available power on that channel when you're driving all 4 channels. And more specifically, when all 4 of those channels have similar source material, maybe similar loads, and you've got similar SPL requirements, right? So what does that really look like, right? And I'm going to use a image from Tesira software, and we'll dig into this deeper later on here. But so if I'm putting together a design and I've got 4 channels here on a 2404, and let's say maybe this is a large concourse or atrium type area, and we've got, you know, IC6, the 1062s there, and we've got the same loudspeaker right across all 4 of our channels. We've got the same number of those loudspeakers, right? So we have 2 wired up in parallel to each channel. And what that's going to do, we got same speakers, same quantity. Well, that's going to present a very similar load to that amp. And if we're pumping the same content out of all that, well, you know, we could expect that the power requirements on each channel are going to be very similar, right? They're going to be in symmetry with each other. And in that case, right, we have 2,400 watts of total power on that chassis that we can provide to those channels. And so that's going to split up across those 4 channels pretty evenly. That's where we get our 600 watts. But I mean, not all things in life are so even in a line. And that's where the sharing between channels can provide a lot of flexibility. So when I think about asymmetrical power, right, it's you know, it's additional power that each channel can give, right? And, you know, assuming that the power supply has it there. But, you know, when you're talking about this power sharing, this asymmetrical power, your focus can be more on sort of the total power and the total channel count, and less about the individual channel capabilities itself. So let's use that same, you know, same 24/4, but let's switch up the scenario a little bit, right? So maybe we have like a bar, lounge, like restaurant style environment, and we have 3 zones with very different needs, right? So we've got maybe like a bar lounge area that's got some low Z subs, some high Z tops, right? And they're supporting music playback in that zone. We've got a dining area on our channel C there that has some of our DP6 pendants. And we drop that preset, and they're just running high impedance to get some background music into a dining area. And then we throw a few, you know, ceiling speakers in the restrooms, right, to get some playback in there as well too. So these are, you know, all very different loudspeakers. We've got very different quantities across all those channels. And as such, we have very different power requirements across all those. And, you know, when we look at the 4th channel, channel D down there, that's serving the restrooms, right, we've got a requirement of just 15 watts to drive those little ceiling speakers. You know, so what do we do with the rest of that power? I mean, is that just get wasted and it just sits there unused? No, we can take advantage of that, right? And that power can be sourced onto other channels with higher power requirements. And so when you look at channel 1, we're able to achieve our 1,800 watts of potential on that channel because we have it available from the other channels to share. So, you know, there's no bridging required on the output side to do this. It's all done by dropping in the presets and setting your power requirements. So yeah, it's you know, creates a scenario where you have you know, potentially maybe a lot of flexibility to drive more different types of loudspeakers with the same chassis, and you're not restricted to that, you know, that's just symmetrical power rating any longer. I want to jump in and go through the chassis. We'll look at the front and rear as we eventually transition our way over to Tesira software. So this is the front panel of Voltera D. Some of this should be pretty self-explanatory or familiar with you, especially if you've worked with Tesira devices in the past. We have a power indicator off onto the left-hand side. That's just power state feedback only, not a power button. And that'll light up green, and that'll give you an indication that the device is powered from either mains or PoE power. And that's very interesting. We'll touch on that here in a little bit, talk about the PoE capabilities on the device. Just to the right of that, we have our system status indicators. Again, these should be very familiar to you if you've worked with Tesira before. This is really a high-level overview of the current status of the device. So a fully programmed, configured device will show you all green. Maybe you have a amber or red on your alarm or AIS, and that's telling you that there's something you might need to investigate with software. But essentially just providing feedback on the various states, and we have information on what all those mean, of course, in the Tesira help file and on Cornerstone as well. The front panel of Voltera D does come with a audible locate feature. Visual locate feature. The locate, it can be initiated from the front panel or from software. When this button's hit, all 4 of those status indicators on that LED ladder to the left of it will flash. You also get an indication in the locate window in software. And this is a good feature, maybe if you have a remote programmer, or you have an installer on site, and you're trying to sort out sort of the installed location of devices seen in software. A programmer can initiate this from software, a technician can find the flashing device, and then they can stop the locate from the front of the unit once that's been identified. We have channel status indicators. This will give you feedback on each of your 2, 4, or 8 channels, depending on your model. We'll have channel temperature feedback there, with feedback indicating whether the limiter has been engaged or not. We have signal presence for each channel, as well as a mute status indicator. And I definitely don't want to neglect to mention, under that nice grill there on the chassis is a couple of filters. So it's easy to remove. It's just basic magnets. You push onto the sort of top right-hand side of the grill there, right where you see the Voltera D model name. And then it's going to cantilever out the other side and allow you to just pull that grill right off. That'll reveal the 2 filters, and then the grill just snaps back on via the magnets. So real easy to take on and off. Of course, filter maintenance, cleaning requirements, all that are going to be dependent on install location, site conditions. But just be aware that they're there and something that should be followed up on during regular maintenance. I want to swing back around the unit to the rear panel. So all models are going to have analog inputs. Note these are all line level, so no support for mic level inputs here. You're going to get 1 per loudspeaker output. So that's going to be 2, 4, or 8 channel configurations, depending on the model. These analog inputs, when programmed from Tesira, can provide support for failover from network media sources coming into the Voltera D, or you can actually pull them out of Voltera D and use them as general input expansion into your Tesira system. So think you have multiple Voltera Ds across the facility, maybe you have a music player plugged into one of them, and you want that to be available to all outputs across the facility. Well, you can bring this input block out into your Tesira file and use some of that DSP overhead or a Voltera DM to get that routed to all the rest of your loudspeaker outputs. Okay. Speaking of which, of course, we have loudspeaker outputs from our amplifier here. Those are going to come in 2, 4, 8 channel configurations. Notice I mentioned before the 2 channel are only going to be available in Voltera DM, and the 8 channel only available in Voltera D. The 4 channel versions are currently available in both. We have a logic IO. This is completely customizable in Tesira software, and from a performance standpoint, you could think of this as akin to the logic IO that's on a Tesira Forte or server IO, right? So we can bring logic inputs in or send logic outputs out, customized based on our needs in the program. But in addition to that, we also do have some fixed GPIO. So this is all dedicated functionality that ports right below the logic IO at the rear of the unit. So again, the logic I/O is the Tesira customizable logic. This GPIO is dedicated for Voltera D itself. So those pins on the back, pin 1 is going to be an input. Tying that to ground will do a kind of a mute all. So maybe that'd be a place to connect up to a fire panel or other device if there's requirements to mute all audio under certain conditions. Pin 2 is going to go active low if there's a fault in the system. So you get some health status there. So maybe you have a media fault or some other thing going on in the device. It'll give you some GPIO feedback from pin 2. Pin 3 is going to provide information on standby. So if the unit's in standby status, that'll go active low as well. And how do we get it in standby? Well, that's pin 4. So we get mute all, we can confirm health status, and we can trigger and monitor for standby conditions as well from that GPIO. Seems self-explanatory, right? But we have a mains power connection on the back there. I only call it out because as we get into our networking section here and talk about our networking interfaces, we will touch a little bit on the PoE behavior of this device. That's probably a good segue. So we've reached our network ports to talk about networking in Voltera D. So I akin this to again, maybe a rack mount Tesira Forte. I think the comparisons can help if you're familiar with it. If not, we'll go through all the details here. But port 1 on the device, you could think of as the control port, possibly on a Forte at this point, right? At this point in time, it provides control communications for software programming, right? So that's where you get it out of the box. You want to make an ad hoc connection to it and start programming it. You plug your PC right into port 1. Like all of our devices in this family, we have they result to a PIPA address when they boot up. So with your computer on DHCP, you can easily discover it right away out of the box. Port 1 will also be used if we're doing our separated control and media topologies. And we've had this has been a supported topology in Tesira forever now, since about 2.4 firmware. And when we say separated media and control, we mean just that. They're separated. Your port 1 is off onto one network. Your port 2 is off onto another network. They don't touch each other. They have IP addresses assigned in different subnets, and they're completely isolated or separated, right? Port 1, in addition to the control interface, does support PoE+. And just a quick rundown of why that is there. So the PoE+ power, so let's say you have a situation where battery backup power restore is in play, and it's some sort of consideration on site. You maybe have network switches where they're on a UPS. Well, the PoE+ output of those network switches can be connected to port 1 on Voltera D, and that's going to provide enough power to keep the entire brains of the device alive. So in the event of a power outage, your network switches are still up, providing PoE+ to Voltera D. The entire DSP, both network ports, will remain up and active. And that's really the thing that takes the longest to boot the device. So when, say, the event of a power outage, the brains will stay alive, the amplification stage will go down. As soon as backup generator power, mains power is restored, all we're waiting for is for that amplification to come back. We're not waiting for the entire DSP to boot, its network stack to come up, to get its address via DHCP, and it to sort all that out before it can start playing audio. We're simply just waiting for the amplifier to come back. And for those of you who like to maybe kind of play around or nerd out on some of that stuff, if you have this sitting on your bench too, you can plug it just into a PoE+ port, and that's a quick and easy way to get in and do some programming. P2 on the device. So this is the primary port for media. So this is going to be your connection for ABB and Dante media networks. It will also support our single cable converged. So single cable converged topology has been something that's been around now actually for quite some time as well, I guess, but a little later in the life of Tesira that came around our 3.8 firmware. Single cable converged, port 1 is linked down. There's no other configuration required. So if port 1's linked down, Port 2 is connected. The control interface inside there is going to switch over to port 2, and now your software programming and all of your network media is accessible on port 2. And so in this case, yeah, your control and your media networks are going to be one and the same, and port 2 is the only link required from Voltera D. Note, if you do plug into port 1, that's going to break and put it back into that separated mode. So it does need to remain linked down if that is your intended topology on site. So network media protocols, right? So Tesira's native language, AVB. We speak many, but yeah, AVB is commonplace across all of our Tesira devices. This one supports 32 by 32 channels of AVB, grouped in up to 32 streams, right? And easy integration right into Tesira using implicit AVB, but we do also support explicit AVB for third-party interop, just like many of our other Tesira devices do as well. Voltera D also has support for Tesira expander class devices. So it can act as a proxy for AVB expanders. And so we're talking our XIN, XOUT, XIO, AMP450P, MPX paging stations, EXCBT maybe is pulling audio in from a PC acting as a media player, and it's real nice USB extension to get that audio into your Voltera D. No, I don't have parlay mics listed here. Now, there's no AAC inside of Voltera D, right? So, it's not a conferencing device on its own. Of course, you could add XACs or a Tesira Forte DSP with AC capabilities to get that support as needed. Voltera D also supports proxying of control logic expanders. That's TechX, XLogic. The Voltera D itself, the signal chain inside of there is fixed. We can't get inside to manipulate that, but we do have some control points that are exposed external to the block. And with that, the TechX can go in and we can program the TechX to do some basic source switching, source routing between the inputs and outputs on Voltera D, as well as user input level control. On the Dante side, Voltera D also supports, along with the AVB, simultaneously 32 by 32 channels of Dante, and it's going to be grouped up into 32 flows. We're utilizing Dante's IP core, so the Zinc 7000 in this case. It's the same Dante interface that you'll find in our Forte X, as well as our current shipping rack mount Forte DM products. Realize that this is, to my knowledge, our only current Dante device that now supports 96 kilohertz sample rate. So if you do have a use case for that, Voltera D might be a good fit to bring those sources in. And of course, with our Dante support, AS67 comes along for the ride. Okay, so let's talk a little bit about, how do we actually configure this thing? How do we get into it and talk to it? So Voltera D, we do have, as I mentioned, two software options. We have our existing Tesira platform and the new VenueTune software. But how do you know which one's right? Well, today we're here talking about Tesira. Presumably many of you are Tesira programmers. You're probably going to feel maybe more comfortable in that sandbox to begin with, and there's no reason not to stay there, right? Really, where Tesira software is going to shine here, or honestly be required, is if you need input expansion, right? We're adding expander class devices onto the design. You're going to need Tesira software to do that. We need custom input switching and routing ahead of maybe multiple Voltera Ds, right? You're going to want Tesira software to take care of that. If there's AVB involved, right? So again, that sort of goes without saying with the expanders, but if you have any AVB audio involved, Tesira is going to need to get your main software for programming and configuring Voltera D. And as we talked about the input expansion, again, if the analog inputs on Voltera D need their sources connected to them need to be available to other Voltera Ds on the network, then the flexibility you have in Tesira software is going to be the way you want to go. VenueTune, exciting new software offering. It is more loudspeaker focused, right? It's, you know, it sounds silly to say, but it's more venue focused, right? You can import floor plans, layouts, you know, your building, adding in the amplifiers, adding in your loudspeakers, and it's very focused on the loudspeakers itself. Configuring from venue tune will support Dante, so we have no AVB support from there. And the analog inputs are specifically acting in a failover capacity for their local Voltera D. So this is Voltera D configuration only. There's no other Tesira devices or Biamp devices involved. That software will recognize, discover, and program Voltera D and or Voltera DM devices for their loudspeaker outputs. When you get a Voltera D, you first fire it up and connect to it. It's going to have a default configuration running. And so Voltera D out of the box is venue tune ready. So you open up venue tune software, go online, and it's ready to be configured. So what that means from a Tesira standpoint is if we want to do some custom programming here, we're going to need to clear the configuration. So first thing you're going to want to do as a Tesira programmer when you get that Voltera D on your desk is you're going to want to clear configuration and get that device ID to 0. If you have a unit at your shop that has had its configuration cleared and you realize that there's a situation where venue tune software is going to be used, well, a simple factory reset of the device will restore that default venue tune configuration, and you're back into a situation where you can utilize that software again. And really it is, I mean, it's a Tesira device at heart. So that default configuration under the hood has all the ALC processing that's inside that Tesira block, along with the corresponding support for the Dante inputs. The block dialog for Voltera D, that is a output block in Tesira. So that'll be in the IO section. We'll go down to amplifiers, and there we have Voltera series. Voltera series is going to encompass the original Voltera A, as well as all the Voltera D and DM that we're talking about today. You just select your model, and then the initialization dialog will leave you with options to either enable or disable the logic IOs. And those logic IOs can give you a mute all input from Tesira, as well as feedback on health status. We can also define the analog input mode from here. And so that's going to be either analog failover, or if we want to pull that input block out of the Voltera D and use that somewhere else in our Tesira layout. So here we have, an entire block family of Voltera D. They look like a typical output block in Tesira, but I'll tell you, there's so much going on inside of there. And so let's take a little look at the signal flow. So inside Voltera D, you're going to come in on those input nodes there on the left-hand side of the blocks. And first thing you're going to hit is you're going to hit input priority routers. So this is where your Dante or AVB is coming in, possibly getting mixed in with your analog signals. We have some settings here where you can set gain, delay, and trim, and set up your, if you're doing failover, you can set up how your failover is going to behave, what analog channels or each digital channel going to fail over to. We have a matrix mixer. That matrix mixer inside allows you to take any one of the inputs coming into that block and route it to any of the outputs coming out. And that is matrix mixer style. So, right, we can do one to all, one to many, one to one, and a mix of all of those inside. User input. So this is always going to be accessible. The user input is our first device that's utilizing raise cosine EQ. I encourage anyone, if you've got the software, to kind of play around with that, and it is smooth. We got 16 of those filters on each user input. We got up to 2 seconds of delay, as well as sort of typical gain, mute, and polarity controls, and a metering. After that user input, we get into the loudspeaker portion, and pay close attention to this because the majority of the time you're not even gonna have to think or worry about this. This entire section, this whole portion of the signal flow is defined by the loudspeaker preset that you pull in, right? And there's no modification done. In fact, when you pull a loudspeaker preset in from Alamos, all of this is grayed out, locked out. There's no need to go in and change any of the settings, you have all the settings right there that you need for the loudspeaker that's been assigned to that channel. You have your user input to do any sort of colorful EQ or gain settings, mixer to change your routes. But in here, all of the optimal loudspeaker settings that we've defined in those presets are deployed. We can create user loudspeaker presets, so you can create custom ones that, of course, will open up this section, and we'll take a look at that here in software in a few minutes, but and allow you to define these yourself based on the loudspeakers that you're working with. But again, that's where the advantage of Alamos comes in, right? You drop the Alamos preset in, and you're simply worried about your user input, setting your gain settings, and maybe other, some colorful or corrective EQ you want for the space. Everything related to your loudspeaker is already done for you. And then we're always monitoring, right? So we're monitoring the power supply status, temperature, voltage, current, as well as each individual channel for those as well. And there is a health statistics graph and feedback inside of Tesira software that'll give us a status on this and let us know if maybe we're getting into a situation where we might have a problem. And with that, I think that's a great opportunity for us maybe to shift gears a little bit and get ourselves on over into Tesira software. So I'm going to add in, just kind of step through here and show adding of a block. We'll do a little basic configuration, and then I've got a live system set up that we'll jump into and just kind of walk through the signal flow here together with some things active and happening going on. So I'm going to go down here to our I/O section, a little purple bidirectional arrows over here, over to amplifiers and our Voltera series. When I click that in my layout, I'm going to get my initialization dialog and use my drop down here to clue in on the D or DM model that I have. I think, let's pick one of these. We'll do the 1200.4. From here I have options where I can enable or disable the logic nodes, as well as define my analog input mode. I think it's important to know what this is going to be ahead of time before you get deep into the configuration of the block. And why? Well, once you drop that block in, with everything that's going on inside, the analog input mode can't be changed once the block has been added. So if, let's say we drop this in with analog failover and realize we want to do analog input mode, we'll need to, at that point, to delete and drop in a new block. Make the correct selection that we want for our application. And then we get that analog input block going along in the file that we can use to bring in and distribute sources to multiple devices. Okay. Once I have my Voltera D in the layout, some of the other Tesira devices, I just need to double click it to open up my control dialog. Okay. But our control dialog is very different because we're giving you hooks and controls and levers to pull at various stages throughout that whole signal chain that we looked through. So when you first open this up, a lot of times it'll bring you to the config section right here. And this is the first thing we need to do, right? We need to drop loudspeakers into our layout. And so what does that look like? So we have our 4 channels here, A, B, C, D, equating to channel 1, 2, 3, and 4. We have a folder here. We'll hover tips when we go over top of them. But that folder is going to open up our Alamos loudspeaker library. Okay. And there is a lot in here, right? But we have search tools, filtering options that we can use for the various columns. And let's say I know I'm working on something where I'm going to be putting in a number of zones with pendant speakers. Maybe we've got a long concourse or something along those lines where we're just pumping in some background music in an open ceiling environment. So I can come in here, select the loudspeaker I want. I just can hit OK, or I can double click it to add into my layout. I can go ahead and I can duplicate this across all channels. It'll remember the loudspeaker I was last on, so I don't need to go searching again. Just make sure I keep selecting the full range version of that. And now I've just populated all my channels with the right preset EQ and limiter settings for my DP6s. Now I have more I can do here. You know, by default, they drop in with low Z mode, but we do have transformers on these speakers. So I can come in here and set my various tap settings. Per channel, right? And you know, with high impedance, we likely have some of these in daisy chain. So I can use the up-down arrows to change my quantity, or I can just come in and type a quantity here into the window. So let's say maybe we have 15 on each one of these runs, and maybe we got 10 loudspeakers on these other two channels. And as I made those changes, our power requirements changed. Now, if I go down and I only need 5 of these on this channel, well, that drops me down to 150, right? So we can see everything update in real time. And the thing I want to point out about this, now that I've dropped all those loudspeakers in, is this is a 1200.4. Our 1200.4 has an asymmetrical power rating, or has a symmetrical power rating per channel of 300 watts. Right, so 300 times 4 gives us our 1200. Okay. If you notice, we got 450 watts potentially on each of these two channels. That's fine, because our total, we have up to 900 watts of power that we can source on each one of those outputs. We only have 150 on our others. When we add all that up, we've got our 1200 watts of total chassis power. So this is where a lot of the flexibility comes into play, right? We have zones that have more requirements than others, and so we can leverage that power sharing inside of here to help support those larger zones that we might have. Now I already have a system set up here that I've gotten ready just to show maybe a little bit more beyond what we can just do with a single Voltera D. So in this setup here, I've got Voltera D 2404 as well as a 2400.8. I'm bringing in, get this set up. Bringing in sources via my EXCBT. I have Dante inputs coming into my 2404. I have Dante inputs coming into my 24.8. I also have analog inputs as well here available to the system from my 8 channel. My 4 channel is actually in failover mode. So we'll take a look at the failover behavior here. So we can see here, I've got audio from a media player there on the EXCBT, and I've got some content coming in on my Dante inputs as well. One of my Voltera Ds is hosting this 24/18 matrix mixer, right? I've got my 8 channel is acting as the proxy for the EXCBT and the AMP 450. And maybe that AMP 450, yeah, we're just a single channel down there. So maybe we got just a small little overflow space. All channels on the Voltera Ds are used up, and we just need to get a single little channel in a small auxiliary room somewhere. That's maybe a great fit for that. We can take a look at our 2404 here. Pull this onto the screen. So I've opened up the control dialog for the 2404, brought us to the config page, and we can see I've dropped a couple of Biamp loudspeaker presets in on channels 1 and 2. Channel 3, we have a custom user preset, which I'll go back and review the sort of creation of those and how we step through that. Our home screen, it's a good place to start. So home gives us a nice overview of current status of all our channels. You know, is audio passing? Do we have any sort of limiting or faults or errors or something like that reported throughout? Looking here, I can see I have activity coming in on my first 3 channels that are programmed. And as we maybe take a look at speaker 1 here, as I go through our user input stage over to our loudspeaker inputs, Note that these views are hidden. So these views are hidden because I dropped in an Alamos preset. So again, none of this is anything that you need to worry about. You drop the preset in, all of this is preset and optimized for that loudspeaker that you've assigned. But in cases where we have a user input, all of this is exposed. And we'll step through the signal flow of one of those user inputs so we can see what the rest of those look like. So from the home screen, we can click on in any one of these areas and that'll take us to the appropriate portion of our control dialog. And so here I want to take a look at the user input for my loudspeaker 3. And so this will give me that I have some level control here, I have mute, I have polarity, I have some delay. Here's where I can add in up to those 16 of those raised cosine filters. We have high pass, various shelf, and PEQ that we can add in. Do the user preset. We have our loudspeaker input stage here. This has classic up to 8 EQ filters, as well as dynamic EQ, which I found very interesting. It's not something I had ever run into in the types of systems that I have worked with and types of environments I've been in. Man, is it cool. It's kind of fun to play around with too. So if you find yourself in a situation where this is something that you're used to working with, or you have a scenario that can be helpful in the maybe type of like live sound or reinforcement environment, this would be a very cool tool to have at your disposal. But it's essentially doing almost like a frequency specific compression in a way. We've got loudspeaker output stage. So this has high pass, low pass, and up to 14 additional filters that can be added in here. The GUI is very similar to maybe an Uber filter you might be used to. Since this is a user speaker, a non-Biamp speaker, we have options in here to import the manufacturer's FIR filter. We can set all other EQ here from here as well, and we have the limiter settings exposed as well. So you've dropped your user input in, you can come in here, you can set all that manufacturer's recommended EQ, import that FIR filter, set your limiter settings, and then once we get back to the config page, you can save. So you can save that preset to your own library, right? And so that'll save that preset with all those same FIR, limiter settings, EQ settings that you've deployed, so you can reuse that on other installs. Of course, with Alamos, it's all there ready and done for you. So you can just simply drop those in. When we look at one of those loudspeaker channels, I have no access or visibility to the output stage or input stage of the loudspeaker, but I do, and I am able to come into the user input and have access to that raised cosine EQ and do any sort of coloring or corrective EQ that I want to from this stage. We have our mixer section. So mixer here, we can impact our input priority routing as well as our routing locally within Voltera D. So I have an external matrix mixer here, right, that's taking care of routing my EXCVT and all my Dante sources to Voltera. But if I had a standalone Voltera system, just bringing in Dante audio and I want to do some local source selection, all right, we have matrix mixer here where we can create various input to output groups, depending on our needs. Note that the 5th channel down here is the included big noise generator. So if you need that to help set SPL levels or anything in your system, tone out speakers, that's already built in. You don't need to add an additional one into your layout. At this input stage here, we have all the inputs available on the device. As we click through them, off on the right-hand side over here, is where we get our digital and analog trim controls, as well as our analog delay. We can see meters of sources that are coming in digital or analog. So looking at input 2 here, I have a source coming in over AVB, as well as Dante. Input 1, I also have an analog source wired up. We have right post the input selector here. We can switch between our analog and digital inputs. So let's say you have a channel that's doing analog only. It's connected directly to the device. You can take the digital aspect out of that and just have that as an analog only source. But more times than not, we'd be using this to impact our failover. So our failover here, we can set 1-to-1 by default. We can also tell, say for example, input 2, that we want it to use analog input 1 as its failover channel. Okay. Now when we look at input 2 on the meter here, we see that we've got that analog input 1 signal, so that when we go through our failover scenario, we'll have that analog input that's coming in on 1 available to, potentially, input 1 or more channels in our layout. And what does the failover look like? So we can look at our home screen here as well too. This will inform us of, not just level coming through, but we have a status indicator over here on the right. And let's say we have some sort of loss that happens on the network, right? And we've had a Dante device that has dropped. Well, we'll get feedback right here of that we've lost network audio. Loss of network audio causes all of these inputs to switch over to analog, right? So they detected that we have a, in this case, it's a Dante flow inactive. Device has dropped off the network, and as such, they have switched over to their analog inputs. Once that's restored, and we clear the fault condition, we can keep an eye on system status. All those inputs will switch back over to digital, and our digital audio paths will be restored. Lastly, in here we have a health section. And the health section is where we contain all that monitoring we were talking about when we were looking at the signal flow. So from here we have graphs that show the overall system or chassis health, right? So we have temperature readout, voltage, as well as current monitoring going on the power supply. And then we also have information per channel as well. And so maybe we're driving things a little too hot, or the fans or cooling system in our MDF went out and we're starting to have problems. We get maybe fault warnings or some sort of notice. We can come in here and maybe dig in a little more to see what might be going on. I did neglect, I had wanted to show user input creation specifically. So obviously we'd love if you're using our Biamp loudspeakers and presets from the Alamos library, but we do have the ability to create custom user presets here. So when you come to a channel that might have that requirement, instead of opening up the folder here for the Alamos library, we can come right in here to this plus sign. Get a little hover tick to create a loudspeaker. We open this up. Here we have a variety of fields that we can enter. So we can type in everything from the brand to the model. We can define the, maybe a product family or a specific line, any information here that might be important and or helpful to us. We can define the type of speaker it is, and that'll help maybe in categorizing if we have a lot of these, as well as there's some level of version control. They can also be password protected. So when you saw the Alamos presets and we have all the loudspeaker input and output sections closed off, they are password protected, they're locked. So you can do the same with your user presets, so you don't have someone else who's not you going in and maybe changing limiter settings or EQ parameters, right? Once you've defined sort of the text and the shell that's going to be living in, you come over here to your settings. And from the settings, we can define the power, maybe on the loudspeaker, whatever its impedance is. Does it have a transformer? It does? Okay, well, what kind of tap settings do we have available? So we can enter that in, and all of these then will become available. So we can save this. And save this to my library. And now the tap settings that we defined are available here. I have a single speaker that's showing the power that I've defined. As we raise the parallel quantity, we can see that update as well, along with the impedance. And then when we come into that loudspeaker channel, right, I have the capability to come in and import my FIR filter, set all my limiter settings, and once all that is done, and I have the, that manufacturer's recommended settings in place, and come back to my config here and save that loudspeaker profile with all the updates I've made. And then again, that can be kept in your own library, accessed via Tesira and or VenueTune software, and deploys as needed if you need to recreate install with that same loudspeaker again. So yeah, thank you. I wanted to swing back to that. I meant to do that when I was on this screen here, and got a little flummoxed and jumped over to our live system here a bit too quick. But yeah, so I think that's everything I was prepared to show in Tesira today. I guess, I did want to, before I get over to the questions here, I do have a TechX controlling this system. So Voltera D itself, there's a lot going on in that block. It looks like a normal Tesira block, but it has that whole DSP signal flow under the hood. As a result, there's no direct TTP commands to allow you to go in and manipulate that. The block itself cannot be added to presets. Of course, Voltera D can host presets. So in this scenario, I can have the matrix mixer that it's hosting and level controls and mutes and whatnot added into presets. But if I want some, basic, quick, easy control that I can use to maybe do some source selection or volume adjustments, right? We've actually exposed some of the hooks inside of Voltera D to do this. And so here I have an example of one of the output channels that I've programmed for. And I can select any one of my 4 inputs that are coming into Voltera D and route them to this specific output channel. I have volume control of that user input level control. And the way they've done this is they've exposed. So when they've exposed, let me go offline here. You have your instance tag of your Voltera D block, right? And we can get that, of course, from clicking on the block, and we can see in the bottom left-hand corner of software, I have VDAMP3. And when we find that instance tag in here, we have VDAMP3, but then notice we have 2 choices. We have level 8 and mixer 5. So we have access to the matrix mixer and access to the user level control. And so in this case, I've created some basic source selection where on a press of a button, I come in and I turn whatever cross points are on that channel off. And on the release of a button, we come in and we turn the desired cross point on. So this is clearing out any routes that might already be on that channel and allowing us to define a new source selection. We have an article on Cornerstone that talks about this as well. And of course, if you have any applications or are working on this and have some questions, you can always reach out to Biamp support here and be happy to help. Level control wise, pretty straightforward, like we control any level control, but just note that we're still looking for that same instance tag with the colon and then the level designation, right? So that's telling us that we're going into that block and controlling the level control that's inside of it. After that, right, and volume up is going to do a level increment, and volume down will be our decrement, and we have mute toggling as well. And what that's going to impact here when we look at our control dialog is that level is going to be your user input level control here, that we can control the volume and the mute for. And then in the matrix mixer, we'll be controlling these cross points. Okay, now I officially think I have touched on everything I wanted to touch on today. Again, any questions that you might have, don't hesitate to reach out. We're generally happy to help. Thank you all so much. I really appreciate it, and I wish everyone a great rest of your day.